5 Ukrainian unmanned aerial vehicles were racing across the airspace over the Crimean Peninsula when everything suddenly went dark. The global positioning system disappeared. The control link was cut. On the screen, only wildly shifting coordinates remained along with an invisible wall of electronic interference. What happened next seemed almost impossible. At the same time, 7 other AN-196 Liutyi unmanned aerial vehicles were circling over the central Black Sea, moving toward the Kerch Strait. Their target was clear: a 35-car military supply train loaded with fuel, artillery shells, and weapons. After days of continuous Ukrainian strikes and isolation, that train was nothing less than the last lifeline for Russian forces in Crimea. But Russia was not going to let Ukraine's plan unfold so easily. Russian electronic warfare systems had taken away the navigation system, jammed the signals, and cut off the sensors. What the Russian air defense crews did not know was that Ukraine already had a plan to overcome that system. They were using a tactic Russia had never expected. To reach the Russian supply train, the first step was to destroy its air defense protection. If they missed, all 12 unmanned aerial vehicles would become little more than live-fire practice targets. If they hit, the warning network in the area could be blinded for 20 minutes. But between them and the target stood one of Russia's most modern defensive systems, Borisogledsk-2, an electronic warfare complex trying to jam communications, distort navigation, and push the entire formation off its flight path. Inside the Borisogledsk-2 command vehicle, Russian operators watched every signal line appearing on the screen. The system scanned the entire electromagnetic spectrum, identified the direction of transmission, and then concentrated jamming power on Ukraine's communication channels. Within seconds, the control signals were drowned in a sea of interference. The Russians expected the AN-196 Liutyi unmanned aerial vehicles to lose control, turn back, or crash into the ground. But they waited in vain. The unmanned aerial vehicles did not stay on one frequency long enough for lock-on to them. Every time the Russian system managed to suppress one channel, the signal had already shifted to another. And when the final link was cut, the onboard computer immediately switched to inertial navigation and continued following the preloaded route. Russia could silence the signal, but it could not erase the path already stored in their memory. Meanwhile, the formation of 12 AN-196 Liutyi unmanned aerial vehicles had split into 2 directions. The northern group continued flying deep across the Crimean Peninsula toward the Sea of Azov, while the southern group began from the central Black Sea and moved toward Kerch railway station, extending its route in order to approach the Kerch Strait from the opposite direction. Ukrainian intelligence had identified the positions of radar stations across the area, then combined terrain, the curvature of the Earth, and the limits of the radar horizon to find blind corridors wide enough for unmanned aerial vehicles to penetrate. But staying inside that corridor at nearly 150 miles per hour was like threading a needle in the sky. If the southern formation arrived just a few minutes too early or too late, it would enter the engagement zone of the S-400 system. If it drifted away from the programmed flight path, Buk M3 batteries near the Kerch Strait could detect it and shoot the unmanned aerial vehicles down one by one before they had time to link up. So, the northern group deliberately flew slower and allowed its signal to appear more clearly. It acted as the decoy, pulling Russian radar and air defense firepower toward the peninsula. While the combat crews focused on tracking those targets, the southern group dropped to only 50 feet above the sea surface, slipped beneath the radar horizon, and raced toward the Kerch Strait to form a pincer movement. The plan began to work. On the command screen, the Russians saw one group of unmanned aerial vehicles advancing from the north, but they could not be certain whether it was the main attack force or only bait. They were forced to choose: concentrate all air defense to the north and leave the seaward approach exposed, or divide their forces and face the risk of both groups breaking through at the same time. They had only a few seconds to decide. The final attack on the Kerch Sky, a substation, required a completely different tactic. The 220 kilovolt substation near the Kerch Strait was the main receiving and distribution point of the Tumen Crimea power line, supplying energy to military bases, radar stations, and critical infrastructure in the eastern part of the peninsula. Understanding the value of the target, Russia deployed 2 Pantsir-S1 systems around the area, turning every approach route into a corridor of fire. Ukrainian intelligence believed they had found an opening. Nearly 1 mile southwest of the target stood a mobile communications tower and several auxiliary metal structures. At an extremely low approach altitude, these obstacles could create a zone of chaotic reflections, temporarily shielding the unmanned aerial vehicles from the radar line of sight. But the intelligence data was 1 week old. If Russia had moved a radar vehicle, raised an antenna, or changed the surveillance direction, the blind spot would turn into a trap. No one would know for certain until the first unmanned aerial vehicle flew into it. The mission would live or die in the final 500 YD at 150 miles per hour. An AN-196 Liutyi covered that distance in less than 7 seconds. That was also the entire amount of time the Pantsir-S1 crews had to detect, classify, rotate their weapons, and open fire. With 230mm 2A38M automatic cannons waiting, 7 seconds was still enough to tear an unmanned aerial vehicle apart. One aircraft had to go first, betting everything on outdated data. But Ukraine needed at least 3 to get through. 1 to strike the main distribution equipment, and 2 as backups for the next phase at the Kerch Strait, after pulling most of the Russian air defense toward the northern part of the peninsula. The final 3 aircraft in the decoy formation suddenly broke away, dropped altitude, and turned toward Kerch. They began using a technique known as airflow through the radar gap. Instead of flying straight, the unmanned aerial vehicles repeatedly hid behind coastal terrain, low hillsides, and reflected interference from the sea surface. They only rose above the horizon for about 5 seconds to correct their heading, then immediately dropped back down. 5 seconds was enough for the camera to confirm the target, but too short for Russian radar to complete the cycle of detection. Classification, track establishment, and fire control data transmission. Every time a suspicious signal appeared on the screen, the unmanned aerial vehicle had already vanished into the interference layer close to the sea. At Kerch, both Pantsir-S1 crews were already on alert. Each system carried surface-to-air missiles and 2 twin-barreled 30mm 2A38M cannons, with a rate of fire of 5,000 rounds per minute, enough to create a wall of bullets if they could establish a stable track. But the Ukrainian formation did not give them that chance. The unmanned aerial vehicles hugged the sea surface, using the curvature of the earth, the coastal terrain, and water surface interference to narrow the radar's field of view. The problem for the Pantsir-S1 was not a lack of firepower. The problem was that the target only appeared when the distance had already become too short, leaving only a few seconds to react. Through the thermal camera of the lead AN-196, the Kerch transformer cluster finally appeared beyond the security fence and the power distribution structures. According to Ukraine's target diagram, this was the heart of the power network in eastern Crimea, supplying energy to at least 6 military and air defense areas around the Kerch Strait, including S-400 positions, protecting the Kerch Bridge and mobile Buki M3 batteries. Guiding the substation would not immediately paralyze the entire air defense system because critical units still had generators and backup power sources. But the process of losing grid power, switching to backup supply, and restoring communications could interrupt radar operations, reduce coordination, and create a short gap in the defensive network. And that was when the real plan would begin. The 3 AN-196 Liutyi unmanned aerial vehicles split into a pincer formation when they were still 2 miles from Kerch. The lead aircraft suddenly climbed to 250 feet, deliberately rising above the sea surface interference and allowing its signal to appear clearly on the radar screen. Both Pantsir-S1 batteries immediately turned their sensors toward it. Only a few seconds later, the first burst of 30mm fire ripped across the sky, forming a wall of steel directly along the approach route. But that was exactly what Ukraine had been waiting for, while the Russian radar and weapon systems focused on the higher-flying target. The other 2 unmanned aerial vehicles stayed close to the ground and rushed toward the substation from opposite directions. The second aircraft suddenly appeared less than 200 yards from the fence, too close for the Pantsir-S1 to complete a new tracking cycle in time. The Russian crews had only a few seconds to switch targets, but the second unmanned aerial vehicle had already crossed the fence, skimmed over the roof of a maintenance building, and disappeared from the line of sight. At the same time, the lead aircraft began changing direction repeatedly between the 30mm tracer streams. Instead of flying in a stable arc, it suddenly dropped altitude just as the gunner finished calculating the lead point, causing the entire burst to pass ahead of the aircraft's nose. By changing course at exactly the right moment, the Liutyi could force the fire control system to calculate from the beginning again. Each time it created only a very short opening, but at 150 miles per hour, 1 second was equal to more than 60 meters. The third unmanned aerial vehicle used that exact opening to rush in from the east. In front of it were 2 rows of 220 kilovolts power lines and the steel structures of the distribution yard, forming a corridor only a few dozen feet wide. It lowered its altitude and flew straight into the middle of the power line network. Now, the Pantsir-S1 crews faced an unacceptable choice. If they continued firing, 30mm rounds could strike the transformers, switching equipment, or high-voltage lines they had been assigned to protect. But if they stopped firing, the unmanned aerial vehicle would have an almost straight flight path to the heart of the Kerch Strait, a substation. The high-flying AN-196 was less than half a mile from Kerch Strait when the Pantsir burst of 30mm fire caught up with it. One round tore through the left wing, sending the unmanned aerial vehicle spinning sideways before it exploded directly above the fence. But that was the perfect moment, while the 2 Pantsir-S1 crews were still tracking the burning debris. The remaining 2 Liutyi unmanned aerial vehicles burst out of cover at the same time. One skimmed over the roof of the maintenance building. The other passed through the corridor between the 220 kilovolt power lines. Both converged on the auto transformer from opposite directions. The first impact struck the cooling system. The 150-pound high-explosive-shaped charge warhead detonated on contact, creating a high-velocity jet of metal that pierced the steel casing and ruptured the cooling pipes. Tens of thousands of liters of insulating oil immediately sprayed out, coating equipment that was still energized. 2 seconds later, the final unmanned aerial vehicle slammed into the upper section of the transformer, where the bushings and main conductors were concentrated. The explosion shattered before, and 220,000 volts of electricity to arc across the air that had just been ionized. The air turned into a conductor. Electrical arcs stretching dozens of feet swept across the substation yard, melting copper and steel, and igniting the oil that was already spilling out. A fireball rose more than 200 feet into the air, while the shockwave shattered the windows of the control building. Protective relays immediately sent the command to open the circuit breakers. But the damage had already spread into the busbar system before the faulted section could be isolated. In just a few seconds, Kerch Strait lost most of its ability to receive and distribute power from the Taman-Crimea line. Diesel generators at the air defense positions around the Kerch Strait began to start up. But switching power sources, restarting radar systems, and synchronizing command networks all took time. Ukraine did not need the entire network to shut down completely. They only needed it to slow down for 20 minutes. And as the column of fire from Kerch Strait lit up the horizon, the remaining 9 AN-196 unmanned aerial vehicles had already changed course and were racing straight toward the military supply train standing at Kerch railway station at 0440 hours local time. The Buk M3 combat crew protecting Kerch railway station watched the entire air defense picture in front of them fall apart. The incident at Kerch Strait substation did not cause the Buk M3 system to lose power. The diesel engine was still running, the 9S-36M engagement radar was still rotating, and the 69M317M missiles on each launcher were still ready to fire. But the Buk M3 was only one link in a network that included Nebo-M radar, the 9S-18M13 Kupol acquisition radar, command posts, and data links around the Kerch Strait. Now that network was flickering. Backup power sources were being activated one after another, but each switching event caused screens to shut off, data links to break, or target information to disappear for several seconds. Tracks that NIBOM had once detected from dozens of miles away no longer appeared consistently. The Buk M3 crew still had firepower, but they had almost lost their long-range eyes. They would not know the attack was coming until the unmanned aerial vehicles appeared on their own radar, and by then they would have only seconds instead of minutes 3 miles south of Kerch Station. The 4 remaining AN-196 Liutyi unmanned aerial vehicles were racing through the rain. This unmanned aerial vehicle group had circled down the southern side of the peninsula, followed the coastline, and converged near the Kerch Strait exactly when the substation was struck. They approached by using infrastructure to hide their radar signature. Instead of flying across open ground, the unmanned aerial vehicles followed the railway, industrial zones, and power lines. Steel rails, utility poles, freight cars, and coastal structures created complex reflection zones, making the small signals from the unmanned aerial vehicles easier to blend to the ground. Clutter. Russian radar does not automatically treat every object near a railway as a maintenance vehicle. But when a target flies low among hundreds of metal objects and appears for only a few sweeps, the system needs more time to distinguish clutter, ground vehicles, and a real threat. That was exactly the time Ukraine was exploited. The AN-196S maintained an altitude of only a few dozen feet, staying below most of the line of sight of the NIBOM radar at Kerch. When the railway crossed open ground, they dropped even lower. When they encountered warehouses or tree lines, they climbed only high enough to clear them, then immediately dive back down. But the entire plan depended on timing. Ukrainian intelligence believed that at around 04:45 hours local time, after a long night on combat duty, the Buk M3 crew usually had a short lull. One person would leave his station to make coffee, while the others checked logs and exchanged equipment status updates before dawn. Normally, that pause did not create danger, but this morning, it coincided with the moment when the power network had just collapsed. The 4 Leleka 100 unmanned aerial vehicles entered the final corridor in a spaced formation. The global positioning system had weakened, forcing them to rely on inertial navigation, the pre-programmed flight route, and landmarks visible through the thermal camera. A curve in the railway, a small bridge, a row of warehouses close to the water. Each landmark confirmed that the formation was still heading directly toward Kerch Station and the 35-car military supply train. The pilot of the lead aircraft quickly noticed something unusual. The light poles along the railway should have appeared clearly on the camera. Now they were only black shapes. The entire area ahead had lost power. That could mean the strike on Kerchanskaya had succeeded more than expected, or the Russians were deliberately turning off the lights to set a trap inside the Buk M3 combat vehicle. The Russian radar operator narrowed his eyes at the 9S-36M radar screen. Power inside the vehicle remained stable, but data from the command post kept appearing and disappearing. The Kupol radar had just sent back an incomplete track to the south when the data link was cut again. A bright dot flashed inside the ground clutter, then disappeared. 2 seconds later, it appeared nearly 1 mile closer. The radar operator immediately narrowed the scan sector. A second target appeared behind it, then a third and a fourth. All were flying so low that their tracks were repeatedly masked by terrain, train cars, and buildings along the railway. Too stable to be birds, too fast to be ground vehicles, the crew commander immediately ordered 49 M3 17M missiles to be launched. The first 2 missiles left the launcher almost one after another, climbed vertically into the sky, and then turned sharply south. The 9S-36M radar maintained track long enough to update their mid-course guidance. The first 2 missiles hit their targets. Consecutive explosions tore apart 2 Liutyi unmanned aerial vehicles, forming bright fireballs in the rain before burning debris fell into the area beside the railway. However, immediately afterward, a power source switch at the command post interrupted the radar data link. The track when the 2 remaining unmanned aerial vehicles dropped lower behind the freight cars. As a result, the final 2 missiles could not update their targets accurately. One overshot and self-destructed over the water, while the other crashed into an empty patch of ground near Kerch Station. just as the Buk M3 crew lost track of the two unmanned aerial vehicles from the south. The northern group also appeared on the horizon. The two attack axes had now closed in on the Kerch Strait from opposite directions, forming a pincer around the railway station. But the Russians had prepared one final defensive line. Two Tu-38 Derivatsiya PVO anti-aircraft gun systems had been moved in to protect the supply train during its stop at Kerch Station. The Tu-38 used passive electro-optical and thermal sensors. They did not need to emit signals to find targets, and they were not completely blinded when the data link from the command post was interrupted. The thermal cameras immediately detected 7 hotspots moving through the rain. The automatic tracking system locked on two targets from the north, and 2 targets that had just slipped past the Buk M3 from the south. Less than 3 seconds later, both 57mm guns opened fire at the same time, at a rate of about 120 rounds per minute. The program shells detonated directly in front of the unmanned aerial vehicles' flight paths, throwing out dense clouds of fragments. The first lost a wing and crashed onto the railway tracks. The second was torn apart over the cargo area. The 2 southern targets were also caught in the crossing burst and turned into fireballs that fell on both sides of the station. 4 unmanned aerial vehicles were eliminated in just a few seconds. But the remaining 3 immediately scattered. The lead aircraft pulled its nose sharply upward, deliberately making its thermal image stand out against the cold sky. Both Tu-38 systems immediately shifted their tracking onto the most visible target. The 2 turrets elevated and kept firing 57 Epelmitzer rounds at the intercept point ahead of it. That was exactly what Ukraine had been waiting for. While the 2 Russian crews focused on the unmanned aerial vehicle climbing upward, the other 2 dropped to ground level and split in opposite directions. One looped around the row of freight cars to the west. The other hugged the storage yards to the east, using the structures and the train itself to block the line of sight. The electro-optical system still knew where they were. But knowing the position did not mean it could fire. Each gun could only be aimed along one firing line at a time. To switch to the 2 targets circling behind them, the turrets had to abandon the unmanned aerial vehicle above, rotate almost in the opposite direction, and establish a new intercept point. At a distance of less than half a mile, that process took too long. The decoy unmanned aerial vehicle kept climbing through the fragmentation burst, holding all the firepower pointed upward. And below, the final 2 Liutyi had already slipped past the flanks of the 2 S-38 systems. At the same moment, they turned their noses toward the 35-car supply train, locked onto the target with their thermal cameras, and began the final dive. The Russians had shot down 4 of them, but the last 2 had broken through behind their backs and were now preparing to deliver the final strike. At 4:48 hours local time, the decoy Liutyi was torn apart by 57mm fire above Kerch Station. But at the very moment, the 2 Tu-38 systems were still tracking the burning debris. The final 2 AN-196s had already slipped behind them and begun their last dive. Their thermal cameras revealed a scene far beyond what Ukraine had expected. Stretching across multiple rail lines was a 35-car military supply train loaded with fuel, artillery shells, and weapons. After days of strikes and isolation in Crimea, this cargo was nothing less than a lifeline for Russian forces. But Ukraine had only 2 unmanned aerial vehicles left. One had to hit a fuel car. The other had to destroy an ammunition car. If one of the 2 missed, the fire could be contained. If both succeeded, the entire train would turn into a chain reaction that could not be stopped. The first dropped to just 50 feet, raced along the tracks, and locked onto the 3rd tank car. Each car could carry about 75,000 L of diesel fuel. The second approached from the opposite direction, aiming at an ammunition car near the center of the train. 2 targets, 250 lb high-explosive fragmentation warheads. Only seconds remain. The first impact tore open the body of the tank car. The blast wave shattered the welds, sending tens of thousands of liters of diesel spilling across the tracks. The fuel did not explode instantly like in the movies, but red-hot steel fragments and sparks from the destroyed electrical systems quickly turned it into a river of fire beneath the train 6 seconds later. The second unmanned aerial vehicle struck the ammunition car. The 150 lb warhead bent the steel walls and hurled thousands of fragments into the pallets of 152 mm artillery shells and propellant charges inside. The first explosion was contained by the rail car body itself, producing a deep muffled blast. For a few seconds, it seemed like nothing had happened. Then the car exploded. The steel roof was blown away. Fragments ripped into the neighboring cars, and the sea of fire below had already spread to the rest of the train. The artillery shells heated up and began detonating one after another, driving the chain reaction in both directions. In less than a minute, the column of fire had risen hundreds of feet into the air. The rails warped, the braking system was destroyed, and multiple rail cars were torn from their couplings. The 35-car supply train can no longer move. 2 unmanned aerial vehicles, 2 precise strikes, 1 supply line cut at the Kerch Strait itself. The strike did not just destroy fuel and ammunition, it forced Russia to shut down the railway line, deploy repair crews, and disperse even more air defense assets to protect the rear. Ukraine does not need to destroy every train. It only needs to prove that no train is truly safe anymore. In your view, which step was the decisive factor in the success of this plan? Leave a comment, and let us keep moving toward a just